Thank you guys all so much for coming out for DBT, but also coming over to the Bowery House. This is our first use of our newish office for a meetup, and I would say we're pretty happy with the vibe, so we'll be doing more. But it's really great to, I think we all love being part of the DBT community because it feels like we all like this tool and it's fun, and we like other, like meeting other people who use it. So fun to host that moment. So we're going to share a story of a project that we worked on recently, migrating 387 DBT models from Redshift to Snowflake. The goal here is not to do a Snowflake commercial, although that is what we decided to use, but to tell an engineering story that hopefully is relatable and potentially relevant to a decision that you or your orgs might decide to make. And one of the hard things about these kind of platform decisions is you can do your research, but it's limited how much you know about what's going to happen next. And so you have to take a leap of faith. So we're hoping that a little bit of our story will make that less of a leap of faith for you. Just a little bit of context in case Bowery Farming is something you saw in the DBT meetup and that's all the context you have. We design, build, and operate indoor vertical farms growing produce that ends up in grocery stores around New York City, New Jersey, and now the Baltimore, Washington, D.C. area. So we have huge warehouse size, distribution center size, fully enclosed buildings, LED lighting, robots moving things around, growing crops that have no need for any sort of pesticides or anything. And the fun part for us is we're measuring and controlling every aspect of these crops' experience, and we have hundreds of thousands of them a year. So all of the data science that has worked so well in the ad world and in the product world, now we have the opportunity to bring it to the agriculture world. So that's what we're working on. And in that context, I've often told the story in the DBT world. One thing that's great about building this team and building this function is I've never hired anyone with a title data engineering because the tools are so great, DBT is so great, AWS and all these tools are so amazing that you can kind of get away without specializing that for a long, long time. And the other thing that really works to our advantage is we don't get surprise farms. Right? And so there's no Super Bowl spike in traffic that you have to build the whole system around, which is most of the challenge of a lot of these systems. And so it costs tens of millions of dollars. You know about it way in advance. Everyone talks about it for 9 months, and then the farm comes online. So there's no excuse to be surprised by it. And so this last November, the news came out that our farm in Baltimore was opening, and it was 3.5 times as large as our previous really large farm, which was 25 times as large as the farm before that. So these big scale step function sort of changes, but with plenty of notice, right? And so that should, as an engineering team, work to our advantage. So this is our volume of incoming data. So most of our data comes in over a message bus because we sort of all have an internal event-based system. And you can see this is sort of the history from the beginning of our first farm coming online. And you can see this is not a crazy world to engineer for. Things got a little hairy in July. And then the farm launched, and we said, we've thought about this. We have a good scalable system. Whoa! We were more surprised than we thought we were going to be by this moment. So this is when this is when the public found out about the new farm, and this is when we found out about how much that was going to change our world. So two things happened. One thing is it is a lot bigger. And the other thing is one of the improvements, one of the advances we're making in going farm to farm here is bringing more and more information about the farm into the fold. And so there's whole new categories of systems that are part of our data warehousing ecosystem now that weren't in the previous farm. And either we didn't or we couldn't do all the math to understand sort of what sort of situation that would put us in from a scaling perspective. So we started to have some challenges. So this is the runtime for just the transform section of our DBT DAG. And our general SLA for the team is that we run our DBT project hourly, and all of our stakeholders understand that data is roughly an hour old, although try not to get into the details of exactly what that means. And so this is hours to run that part of the DAG on the y-axis, and you can see we're getting closer and closer to just the transform taking an hour, which means we're going to run out of time and not be able to keep this data as fresh as we promise. And that, like, on occasion when things happen, we go over an hour and sometimes well over an hour. So we need to do something about this situation. And so what did we do? This is the AWS Cost Explorer. Depending on whether you're responsible for paying the bills in your organization or not, this is like a familiar color palette. These were the simple days, the one DC too large, you know, it's like the starter package. That was when I was telling people, I don't get why people sign 5-digit contracts with Snowflake. I didn't even have to sign a contract for that, right? I didn't have to ask anybody's permission. I just had my Redshift. And then storage became our bottleneck first. So we got the dense storage, but still the little one, a pair of them. And then things started to, this was like that first ramp of intensity. We went up to 4 nodes. We actually said we were going to do it temporarily until we worked on the models and made them more efficient. That promise was not held by the team. And then you can see, so November is where the volume goes crazy and we need to like start dealing with things, and you see the creativity happening here, right? So we're trying out maybe we can do the 8x compute, which comes with more storage and fit it all on there. Turns out you have to buy 2 of those. You can't buy them in singles, which doesn't work for our budget math. And then this burgundy thing on top here is us trying out Athena, trying to move storage out of Redshift. Anyway, the story is like, we were trying lots of things, right? And we were spending a lot of time trying all of those things. So this is a list of things that we got some amount of the way down the road of trying to solve these problems. So moving a big portion of our schema into Athena that made sense in terms of how we select from it, just sort of the ingest stage. We did that part. We did a lot of instance size juggling back and forth with storage, compute, and counts. We've thought about trying to do multiple clusters. One of our problems was our CI runs competing with our hourly runs, competing with people asking questions, and all of these kinds of problems. So we talked about multiple clusters in different combinations. And then there's this whole like section of, ooh, what if we cook up a lot of Python that intercepts all the messages and does a lot of stuff and pre-processes them and like does all the work that Redshift is not good enough at to be efficient, and we'll save it in Parquet and so halfway through this set of bullets, we said, boy, this is becoming a big thing. And we had a lot of other things on the roadmap that we had promised people, and we're not getting anywhere on those. And so we said, let's just take a minute. Everyone's always like, oh, these other systems are really nice and easy. And maybe my skepticism about the value prop there, this is like a time where you're supposed to consider that. So we said, first step is not going to like do the switch over, like give us our 30-day trial. And we just want to see ballpark-wise performance and cost, and assuming we can trust the community on the rest of the whole like package, right? That like generally you're going to be happy with the rest of it, so long as for your use case, round big numbers, performance and cost work out for you. And so what we did was we took our whole DBT project, took a snapshot of our Redshift data just from the ingest portion of the project, like the load, like the raw part. And then we just did enough of the work on the SQL to get it running. And like weren't worrying about anything else, just like get it all the way through the DAG until it gets to the end. And then, you know, Snowflake is wonderfully abstract in these size units, so we'll try them all. And we could do this much trying in the like $300 they give you for free or whatever. Like this is all just speculative. And we asked the question, can we run this faster somewhere in this range of expense? And can we run it at parity cost, or how much of an ask are we making financially? And this like middle zone here where it doesn't get too expensive yet and it gets pretty fast, seemed from like this stage of analysis, which is not comprehensive, this is like an informed gut call, was both going to be cheaper and faster by a fair margin, and more importantly, gives us a really easy like insurance policy for the next farm, right? Because like we don't want to have this whole conversation for the next farm. And so we said, yeah, we're gonna like, with this data about our application, and the like general community consensus is this is like a reasonable decision. We're going to go for it. We like sign the contract. The Snowflake rep had first contacted me 2 years previously, and I just emailed her and said, send us a contract, we're ready. And it was like the best sales conversation I've ever had. And we said, okay, we're on, let's start doing this. And Snowflake is a $12 billion company, and their whole business is poaching people from Redshift, basically. So we were like, could you please ship us the instruction manual for how to do this as efficiently as possible? And this is what they sent us. Tristan's article about switching from 2.5 years ago. And we're like, well, that's cool, I guess. Like, we like this community too. Surprising there's not a little bit more to work from here. So we thought, while we're doing this, let's write down some of the experiences we have and try to figure out how big of an undertaking is, and then maybe that's helpful to other folks. So the other folks, well, no, you are all the other folks. This is a step where I actually didn't do that much of the work that happened after that. And so Travis is a representative member of the team who did a lot of that work, so he's going to tell the story of what happened next.
Thanks, Sam. Cool. Hi, everybody. As Sam said, I'm Travis. I'm on the data team. I'm an analytics engineer. And so when we finally decided that we were going to transition over to Snowflake, we realized that even though we had this project that was running and actually like getting us results in Snowflake, we had no idea if that was actually correct SQL, or like if the results that it was returning is actually the same as what was in Redshift. And we have about 20,000 lines of code of SQL, so we needed some organized way to go through this and ensure that there's actually parity, so that when we transition over our business users, the only thing they should notice ideally is the bump in performance, and like nothing, not like, hey, why did this graph change randomly from Tuesday to today? So this is like kind of at a high level or like strategy for doing that. So basically what we did is took a like snapshot of all of our source tables in our DBT project, and ran the same exact code in Redshift and Snowflake, and then copied over all those tables from Redshift into Snowflake, and went through a table by table comparison and like row by row to see what were the actual differences. And DBT is actually like super helpful for this, because we're able to like list out like all of the tables that we needed to change and like go through it in an organized manner. So you start out with like the root of the DBT DAG, like the uppermost, like the like grandfather tables, and then go through this like row by row comparison to see if there's any differences. And if there are, investigate in the SQL and say, okay, well, this function is slightly different in Snowflake versus Redshift, so tweak that, rerun it, and keep iterating on that one table until there's no more changes left. And then run that table, everything downstream, and keep plugging through all 300 tables until you're done. Cool. So we were trying to decide like, okay, we could attack this by either having one person work on this project for 2 months, or like have everybody stop what they're doing for like 2 weeks and then just like give it their all. And so we decided to go with the whole team strategy for a couple of reasons. One, everybody has like domain expertise in like different areas, and we're able to like exploit that to like make this process go faster. And two, we're gonna need to become experts in like writing Snowflake SQL at some point, and like what better time to do it than now? Cool. So this graph is showing basically our progress through those 387 models over the amount of time that we've spent dedicated to it. And while of course it's like up and to the right, there's like a bump to it, so it's a little bit higher. Like in the first quarter, you'll notice that we went through 50% of the models just in like the first 10 people days that we spent on the project. And then by halfway in, we're almost at 75%, and we spent that last quarter on the last like 20% of the models. And you can like kind of imagine this, right? It's like you start out with the easy ones. It's like, okay, there's no changes here. You're just like flying through. I'm definitely putting off that one other table that like is terrible and has a bunch of weird joins. And then you like finally get to that table and like finish it at the end. So what were like some of these differences that we saw between Snowflake and Redshift, and what like tripped us up? Tristan's article that was mentioned there actually had a lot of them, but we ran into some others as well. So Snowflake is actually super good at handling JSON, like dictionary objects or like anything to do with JSON. So in Redshift, when you're like when you have a column that's a dictionary, a JSON dictionary, and you want to take that dictionary, each key in it, and like make it into a set of rows, the only way we found to do that in Redshift was have each different key be a different CTE and then union them all in like a Jinja loop, which is less than ideal from aesthetics or performance standpoint. Whereas with Snowflake, this went from like 30 lines to like 2 lines of code, which was really cool. There's an infinity timestamp in Redshift that's like actually kind of convenient, and it's not there in Snowflake. It's nice for slowly changing dimension tables for when the record is like a current timestamp. You can say like, oh, it's like current, the valid 2 is infinity. So in Snowflake, there's 2 different types of nulls. Surprise. A JSON and a SQL null. And if you're like trying to see if a column is null, you can do that if it's a SQL null with the isNull function, but you need to use the is_null_value function if it's a JSON null. Yeah. In Snowflake, left joins with a using clause have an odd functionality, where if you are basically trying to see, so this is a join from one table, left join on another table on an ID column. And in here, if like that ID column doesn't exist in table B, in Redshift, you'd expect that this value to be null because that ID doesn't exist in table B. But in Snowflake, it will just coalesce the value and stick in whatever the ID column was in A. Surprise. And we use that like all the time in our SQL, so it was like a fun one to to transition. And then the last one is you coalesce. In Redshift, least and greatest functions also work as like a coalesce if one of them is null, and in Snowflake they don't. The like good thing about this though is that one person in the team runs into it, and then you put it in a centralized document, and then it's like, okay, I'm like reviewing the next table. I like know to expect these 5 things, and then maybe something else. So just to give you all like a little more context on like what our infrastructure looks like. I think we're actually pretty lucky in that we have very few data sources, and we control most of the data sources. Like most of our data comes from UIs that our software team develops. So people in the farm will like use these UIs, or we have these like automated like sensor systems, and we kind of control that full stack. So it's not that we're integrating like 12 different places where our data could live and don't really have control over it. And as Sam was mentioning, all of that data comes through like a centralized bus in one giant table full of a bunch of JSON. And so what that meant is that when we were transitioning, we really only had to copy over mostly that one load table in between the 2, and then run dbt and expect to get the same results, which like was really nice and like made this easier. There are a couple other data sources for like ad hoc processes. We ingest data directly with Google Sheets, and then also some subsystems that we don't control. For instance, like this fertigation thing. Just for context, like fertigation, so irrigation is if like you're just giving water, whereas like fertigation is if there's nutrients in that water as well. Cool, so we like ingest all that data, goes into our warehouse. Of course, we transform with dbt, which we love. And then what do we do with that data? So we have a bunch of downstream services, like say machine learning processes, or like Slack alerting, or a bunch of other things. Something that we do at Bowery that I hadn't seen before, and I think is actually really cool, is this export schema. So what that means is like if you have all of these downstream services that require data from the warehouse, we materialize the data that they need in the format that they need in like with dbt in the export schema. So the advantage of that is that if you change your dbt project to break those tables, you're notified of that when you're making the change, and not when you're like, when you break that downstream service. And that also made it easier for this process too, because we like had full visibility, or almost full visibility, into like what was being used by our data warehouse. And then the other big thing is like all reporting. most of which for us lives in Mode. And Mode is nice too in that it gives you like a GitHub repository of all of the reports that you've made. So we can go through like systematically and see which queries do we need to update and like what's failing, what's not running. We haven't actually done that yet. That's like the step of the process that we're at. But I'm hoping that it'll be easy given their repository things. But in addition to finishing off Mode, there's also like a ton of other projects that Bowery's working on and like way more things to do than we have like people for. So I'll give it back to Sam to talk about our open roles.